Hey, this is Mr. Ayton. Welcome back to Pre-AP Chemistry. We're continuing on with Unit 13, Thermochemistry, Week 29. Remember, in Week 28, we examined what exothermic and endothermic reactions were. We took a look at an experimental way to calculate enthalpy. That was calorimetry. Well, there's different ways to calculate the enthalpy of a reaction, and that's what we're looking at this week. We're looking at the enthalpies of formation and bond enthalpies, two different specific ways to calculate the enthalpy. And with enthalpies of formation, we're going to use that reaction that we saw with our enthalpy diagrams, which is the enthalpy of a reaction is equal to the sum of, that's what this symbol is right there, the sum of, which is adding up all the enthalpies of formation of your products minus the sum of all the enthalpies of formation of the reactants. Okay, so we're going to take a look at our products minus our reactants, and let's get a good example here. So again, we're taking a look at the enthalpy of a reaction, and first let's take a look at our products. We have two barium oxides, and how much enthalpy does it take to form one barium oxide is negative 550. So to form two of them, we're going to take 2 times negative 550 kilojoules per mole, okay? So you can see how, because we have 2 moles of it, we have to double that. Now, if you can see, what's the enthalpy of formation of O2? Well, the enthalpy of formation of O2 gas is 0. You can't form it. It's elemental. We can't form zinc, solid zinc, or copper, or oxygen gas. God has already done it. It's elemental. So the enthalpy of formation for elemental substances is equal to 0. So that is equal to 0. If they don't give it to you in this table, you know it is equal to 0. Well, we're going to take this products minus the reactants. So what are my reactants? We have barium oxide here, so BaO2, and we have 2 moles of it. And how much for BaO2 is negative 630? Negative 630 kilojoules per mole, okay? And so you can see this is a beautiful way to find the enthalpy of our reaction. So what are we going to do in our calculator? We're going to do parentheses 2 times negative 550, subtract in parentheses 2 times negative 630, and as long as you set this up correct, we will always get the correct answer. We end up getting positive 160 kilojoules per mole, which means this reaction is an endothermic reaction. It's an endothermic reaction because the enthalpy is positive 160 there. And so if you want to use enthalpies of formation, if you see this little delta H of F, enthalpies of formation, we're going to do products minus reactants. Just watch out for those things that are elemental. They won't give you the enthalpy of formation for that because we can't form it. It's equal to 0 there. Well, there's another way to calculate enthalpy, and that is using bond enthalpies. Bond enthalpies. And how do we do bond enthalpies is we are given bonds. Do you see how we've been given all these bonds, all these bond enthalpies, and we've been given the reaction? So the thing that I tell you to do when we do bond enthalpies is to draw out the bonds. So here we have chlorine gas. Chlorine gas, remember, looks like this. And we have fluorine gas. Fluorine gas looks like this. And this is going to produce ClF, chlorine fluoride. So, but it's going to make 2 of these ClFs. 2 of these chlorine fluorides. So I'm going to draw out all my bonds here, And remember, bonds breaking is always positive. You always have to put in energy. It's endothermic. You have to absorb energy to break bonds because these particles are colliding. When they collide with each other, they have to collide with the right amount of energy at the right spot, and it breaks the bond. So how much energy to break this chloride bond is 240 kilojoules per mole. Okay, positive. I'm going to put positive on that. And I also have to break this bond. I'm going to break that bond. And that takes 160 kilojoules per mole because bonds breaking is always positive. So if I add all of this up, it took positive 400 kilojoules to break all these bonds. So breaking bonds is positive. Forming bonds is negative. It gives off heat. You're getting to a lower potential energy. So we're going to form these bonds. And I like to draw this little, like, to break my bonds. And I like to draw an arrow to form my bonds. It lets me understand that I need energy to break those bonds. And I'm going to release energy to form those bonds. And to form a bond, it takes 260. But I'm forming 2 of them. So 2 times 260 kilojoules per mole. So 2 times 260 is equal to 520 kilojoules per mole. And this is going to be negative. I'm going to put a negative in front of that 260. That's a negative. It's exothermic. So just take a look. Who won out? The bonds breaking or the bonds forming? The bonds forming was greater in magnitude. So now to find my enthalpy of my reaction, you can see I add these 2 up together, negative 520 and 400. I don't do products minus reactants. I just take a look at positive for bonds breaking, negative for bonds forming, and that gives me negative 120 kilojoules per mole, which means this reaction is exothermic, and because the bonds forming was greater than the bonds breaking. So we did enthalpies of formation. When you're given enthalpies of formation, do products minus reactants. And we also did bond enthalpies. When do we do bond enthalpies? When we're given the bonds. Okay, and we draw out all of our bonds. Bonds breaking is positive, bonds forming is negative. And we'll practice this in class, guys, for Unit 13, Thermochemistry, Week 29.